Okay, hello class. In these sessions, we will learn operator overloading. C++ has built-in operators such as plus, minus, and divisions. We will overload such operators to make them work with newly defined class types. So let's begin. Operators such as plus, minus, modular, and equalities are nothing but functions that are used with a slightly different syntax. We can write plus operator like this, x plus 7, which is human-friendly notations. Or we can write the plus operator like this way, plus and place x and 7 inside of the bracket. And this is similar to the function-like notations. Whether you use these notations or these function-like notations, plus operator is a function that takes two arguments. In this example, it takes x and 7 arguments and does some operations. So plus operator is just like a functions. In C++, there are many built-in operators. So plus, minus, equal, modular, and divisions, multiplications are all built-in operators in C++. And in C++, you can overload these operators so that they work with types you defined. For example, you can overload them so that they work with operands of class type that you defined. The goal of operator overloading is to make operator work with types you defined. So, but you cannot overload operators that work with built-in types such as int and char. That's not the purpose of operator overloading. And you can only overload already existing operators like this one. This means that you cannot define new operators. So in summary, the purpose of the operator overloading is to make them support newly defined class type. And you cannot overload the operators that work with built-in types, such as int and characters. And you cannot define new operators. So you can only overload already existing operators such as a plus and minus. The way to overload an operator is very similar to the way you overload a general functions. This is the example of overloading plus operators. We are overloading plus operator so that it works with money class type. So money is a class type that you newly define for this example. The differences between overloading plus operators and ordinary functions is this one. You specify the operator keyword followed by the operator symbol plus here. you can place any other operators such as a minus and divisions and multiplications. In this example, we are overloading the plus operator, so we put the plus sign here. The arguments to the overloaded operators can be any type, as long as at least one is a class type. So here there's two arguments of type money class types. You can put any other types here, but at least one argument should be a class type. And they can be called by value or called by reference parameters, and may have a const modifier or not. So you can use a call by value and call by reference and const and non-const parameters. But as we learned in the previous weeks, using call by reference is more efficient for class type. So we are using a call by reference parameter here with a const keyword. And in this example, it returns the value of type money object, but it can return any other types of value, including void as well. And you can also return the built-in types such as int and characters or doubles. You can put any types here, depends on your situations. So this example, we are overloading the plus operator so that this plus operator can work with these new types of class, money. If you look at this example, the overloaded plus operator is not a member functions of money class. So we are overloading the plus operator using global functions, which are defined outside of this class. So as a result, it cannot access the private members of the money class. For example, here, dollars and cents are private member of this money class. And because this overloaded operator is not a member function of this money class, it cannot directly access the dollars and cent member variables of the money class because they are private. We could overload the operator as a member functions. Whether you overload the operator as a member functions or non-member functions, each of the different way of overloading an operator has its advantage and disadvantages. We will look at overloading operators using member functions in the following sessions. The definition of these plus operators add two objects of money class type. So it is a little bit more complicated than the simple arithmetic additions. So this is the definition of the overloaded plus operators. Note that because it is not a member function of money class, it cannot access private members. As a result, it uses accessors and mutator functions to access private members. Here it uses getCent and getDollar accessors to obtain values of cent and dollar, which are private of this money class. So you have to use this like this accessor to obtain the value of the private members. So if you look at these definitions, what it does is that it first retrieves the money stored in these two different objects, and add them to calculate new value. Here it's calculating new dollars and new cents here, and using this new value, it creates a new objects of type money and returns it. So this, because of this overload operator, now we can add two objects of money types using these plus operators. So this new object is a result of adding these two objects. Just like plus operator, we could overload other operators so that it can work with money class type as well. Here we are overloading equality operators. Equality operator is this one, so that we can compare two different objects of money type. This is how you overload equality operators. Like previous example, the overloading plus operators, we use operator keywords and specify the operator symbol here. In this case, the equality operator. And one of the arguments of this overloaded operator must be class type. And in this example, we are passing money class type as a first and second argument. And overloaded operator could return any types of value. Here it is returning Boolean type of value. And again, just like a plus operator example we saw in the previous example, this is non-member functions. And this is the definitions of overloaded equality operators. And because it is not a member function of the money class, it cannot access private members. So it uses a accessor function like previous example here. It uses get dollars and get cents accessor functions to obtain the dollars and cents, which are private to this money class. If you look at these definitions, it retrieves the value of cents and dollar from two different objects, which are given through the arguments, and compares them. And if they are equal, it returns true. Otherwise, it returns false. So because of this overloaded operators, we can now compare two objects of money type. If we don't have this overload operator, we cannot compare money types of objects using these equality operators. So this is the purpose of overloading the operators. We are overloading operators so that it can work with newly defined class types, such as a money class type in this example. Before going into further, let's briefly talk about the return type of the constructor. We learned that we do not specify the return type when we are declaring and defining the constructor. So if you look at this example, these two are constructor because its name is same as the class name. And we are not specifying the return types here because they are constructors. So unlike the functions definitions, function declarations, constructor do not have return types. You might think that the constructor is void functions that does not return any value because there is no return types here. But in fact, it returns a value. It returns an object of that class, even we do not specify the return type here. So record the return statements in overloaded plus operators. This one. If you go back to previous slides, if you look at this overloaded plus operators, it returns objects of money class type, and we are creating new objects by calling the constructor of this money class by passing two arguments. So these expressions invokes the constructors of money class, which receives two arguments. So here we are invoking the constructor, and the results of this constructor is the result of these operators. So this constructor construct new objects of money class type, and it returns it. So constructor actually returns an object of itself. So if we go back to the slide. So these expressions we just saw in the previous example, this expression that returns that is returned is an invocation of the constructor for money. So constructor returns an objects, and we call it as anonymous objects because it does not have any name. So we are constructing new objects by calling the constructor, but it is not named by any variable, so we are calling this new object as an anonymous object. There is one more thing I would like to talk about in the previous example of overloading plus operators. It returns a const value. Why does it return the const value? Think about it. This is the declarations of the overloaded plus operators. It receives two arguments. It's not difficult to understand, and it returns the new types of objects, new objects of money class type. Very logical because it's plus operators. It plus given two arguments are of objects and returns it. But why does it has to be a constant value? Let's first assume that there is no const keyword like this example. This example is exactly saying the only difference is that there's no const keyword here. And this operator, this overload operator also returns the money object. And consider these expressions. And M1 and M2 are objects of type money. Because we overloaded plus operator, we can add these two objects. The result of these addition expressions is new objects of type money because this overloaded operator returns objects of money class type. So because of the overloaded operator, these expressions will returns new objects, which is a class type of money. And we can do things with returned objects, such as calling member functions. So as shown here, we can call member functions because m plus m2, because we just overloaded these plus operators. This plus operator returns objects of money class type. So this expression will result in new objects, which is a money class type. So by using dot operator, we can call the member function of the money class, like this example. So this is legal. But this line is also legal because what we are doing is calling member functions named input. Nothing is strange or wrong here, so it is legal. However, these input member functions, assume that this input member function changes some of the member variables of the objects. So by calling this input member function, it changes the value of the member variable of the object returned by these plus operators. So as we talked about in the previous slides, these expressions plus operation returns the objects, which is known as an anonymous object, that because the object is not associated with any variable, and the anonymous object's values can be changed. Changing the anonymous objects is very strange and looks strange, even though this is legal. But for this example, even though changing the anonymous objects does not cause critical problems in this example, it's just strange. You're changing these objects. But sometimes inadvertently changed objects may lead to some problems. For example, if the returned object is a reference to already existing objects, so if this plus operator returns the reference of already existing objects, then inadvertently changing objects could cause problems because that changes will affect to the existing objects. So by returning const objects, we can prevent mistakenly changing objects. So if you put const here, it prevents programmers from modifying the returned objects. So that is the reason why we are putting const keyword here. Okay. So far we have looked at the binary operators such as and equality. C++ has unary operators such as negations and increment operators and decrement operators. The unary operator is an operator that takes only one operand or one argument. And we can also overload such unary operator just like binary operators. This example will show you how to overload the unary operators. It is very similar to overloading binary operators. It also uses the operator keyword and specify the operator symbol here. The only difference is that we had 2 arguments for the binary operators, but for unary operator we only have 1 argument. Note that the minus operator can be overloaded twice, one for binary operators and another one for as unary operators. So it can be distinguished based on the number of parameters declared in the overloaded operators. So if there is only 1 argument, this overloaded operator is for unary operators, and if there is a 2 argument, the overloaded minus operator can be think as binary operators. So nothing is different. You can overload binary operators and unary operators the same way by using operator keywords and putting the operator symbol here, but the number of parameters are different. And this is the definition of overloaded minus operators. It changed the value of dollar and cents to negative value here. And because this overload operator is not a member function of the money class, just like a previous example, we cannot access the private members. So it uses accessor functions, like in here it uses get dollars and get cents functions to obtain the dollar, the value of dollars and the cents, and it changes the value to minus the negative values by putting this minus symbol here, and using this new value to create the new objects by calling the constructor of money class and returns that new objects. So the returns, so this overloaded negation operator returns constant type of objects, and because the object is not named with variables, they are the object is anonymous objects again. And as I explained in the previous slides, the minus operator can be overloaded twice. So here, one for unary operators and one for binary operators. So if you look at this example, these minus operators and this minus operator behave differently. This one is binary operators, and this one is unary operators. So they are two different operators, and the definition of overloaded of these two operators are different. So don't be confused about them. So the overloaded of this minus operator will receive two arguments, amount 1 and amount 2. And as we saw in the previous slides, the overloaded operator for these negations operator will receive one argument because it's unary operators. So this one, it receives only one argument. So they are two different operators. Okay, so let's look at the demo code for overloading operators. Okay, so this is the demo code for overloading operators. Like we saw in the slide example, this demo code has a class named money, and it has a two private member variable $ and cents, and it has a two accessor member functions, get dollars and get cents, and it has a constructor which receives two arguments. So this is the definition of the constructor. It uses the first argument to set the dollars and second argument to set the cent member variable. And get dollar member function just return dollars, and get cent member function just return cents. And here we are overloading minus operators. And this is not our member functions. It is defined outside of the class. So it's standalone functions, not member functions. And because it received one argument, this is unary operators. And just like we saw in the previous example, it just uses the get dollars and get cents accessor functions to obtain the value of dollars and the cents stored in these objects and change their value by negative value. And using this new value, it constructs the new objects by calling the constructor and returns it. And inside of the main function, we create new objects, which is a money class type, and it prints the dollars and cents of these objects, and it uses these negation operators. Because we overloaded this operator, this will invoke our overloaded operators here. So this overloaded operator returns new objects, which will be stored here. And we are putting the new objects, dollars and cents. Let's compile this program and see the output. Okay, so this is the output of the program. $10 and 9 because we construct the objects M1 by using a 10, 9 value. So here dollar is 10 and here cent is 9. So this is expected result. And we are invoking overloaded negation operator here. So it just changed this value to negative values and construct the new objects by using these new values. So the new object will be stored here. And we are printing the dollar here, which is -10, and cent here, -9. This is also expected value because this overload operator just changed the value to the negative value. So because the dollar was 10, because of this overloaded operator, now dollar is -10, and cent was 9, and because of this overloaded operator, the cent just changes to -9. They are all expected result. Let's remove these comments. Now we are overloading plus operators for 2 int types. So our purpose of overloading this plus operator is to 3 plus 5 is 8, but what we want to do is 3 plus 5 equals 15. So that is the reason why we are multiplying these two arguments here, because 3 times 5 is 15. So we are trying to overload plus operator so that plus operator does not do the arithmetic additions, but it multiplies these two arguments here. Do you see any problems here? So what we want to do is we want the plus operators work as a multiplication operators. So that is the reason why we overload this plus operator like this. Do you see any problem here? Yes, there is a problem. That is the reason why I'm asking the question here. So let's compile this and see whether the result of this program is as expected. Okay, so if we compile this program, compiler error occurs here saying that overloaded operator plus must have at least one parameter of class or enumeration type. So in the slide, I mentioned that the arguments, one of the arguments of overload operator must be a class type. But here, int and int are not class type. They are just built-in primitive C++ types. So compilers are complaining about it. Why do we have to have at least one class type when we are overloading operators? The reason is that, as I already said in the previous slide, that the purpose of overloading operator is to make them work with newly defined class type. They are not for overloading built-in types such as int and characters. So you cannot overload operators for built-in types. And because int is a built-in type of C++, you cannot overload operator for them. So one of the argument, at least one argument must be a class type. That's what this compiler error is about. How about this one? We are overloading these operators. The body of this overload operator is exactly the same as this one. Do you see any problems here? Yes, there is a problem. Let's compile this program. So, compilers are complaining about these overloaded operators. As I also said in the previous slides, you can only overload already existing operators. You cannot define new operators, and because there is no built-in operators for this symbol, you cannot overload these operators. You can only overload already existing operators like minus, plus, modular, and equalities. So that is the reason why compilers throwing arrows here. Okay, so let's go back to the slides. Okay, that's it for these sessions. In the following sessions, we will talk about overloading operators using member functions. So see you in the following sessions.